This is the supercapacitor module itself, 1100 farads, storing 8800 joules at 4 volts. What you are looking at is the reason the charge time conversation changes entirely. No electrochemical intercalation, no lithium plating risk, no capacity fade over hundreds of cycles. Electrostatic storage accepts current quickly because it is not fighting a chemical process. This module is the physical consequence of everything we just discussed, and it powers your entire stack for a full working day. This is the high power charging adapter, 12 volts, 5 amps input, delivering 4 volts at 10 amps to the supercapacitor through the onboard charging circuit. The reason this works safely at this current in under 5 minutes is the low equivalent series resistance of the supercapacitor electrode. I²R heating stays manageable because the resistance is a fraction of what you would find in a lithium cell. Plug this in at the start of a field session. 5 minutes later, you have a full day of operation. This is what full day operation looks like in practice. The Power Program Kit supplies the BLE module, the GNSS module, and the Sensors module simultaneously, the complete Multinav Pro Plus stack from a single supercapacitor charge. The combined draw of these 3 modules is low enough that 8800 joules covers a real working day in the field. No battery swaps, no mid-session charging interruptions, no degraded capacity from the 100th charge cycle. The supercapacitor does not care how many times you have charged it. This is the integrated ST-Link programmer. It sits in the same kit as the power supply because programming and power are not separate problems in field hardware development. They are the same problem. When you need to push a firmware update in the field, the power system that runs your modules also powers the programming interface. The ST-Link handles firmware flashing and live debugging for the BLE module through a flat ribbon cable connection with no additional bench equipment required. This is the complete connectivity hardware included in the kit. Flat ribbon cables and all interface connectors needed to tie the BLE module, the power module, and the programmer together. Nothing is left out, nothing needs to be sourced separately. The flat ribbon format keeps the stack compact for field enclosures and drone mounting. The reason this matters in the context of charge time is simple. A system that charges in 5 minutes and deploys in 2 minutes is a system that spends its time working, not waiting.